Hello everyone, welcome to today's video on Newton's laws of motion. Now there are 3 of Newton's laws and we are going to briefly touch on each of them today and a little bit of what they actually look like in practice. So here we go. Newton's first law of motion is that an object in motion stays in motion and an object at rest stays at rest unless acted on by an outside force. Now, it might sound a little wordy, but if you really think about it, that makes sense. You roll a ball, the ball is going to keep rolling until it gets stopped by friction. If you have an object that's not moving, like the computer that I'm currently working on, it's not just going to get up and move on its own. It's not capable of doing that. So if an object is moving, it's going to keep moving, and actually it's going to keep moving in a straight line in one direction, and an object at rest is going to stay there unless something comes up and moves it. Now, this first law is also sometimes known as the law of inertia. Now, this is important for tomorrow. Inertia is the tendency to remain unchanged. So the tendency for things to stay at rest and the tendency for things to continue in moving in a straight line until they are stopped. Okay, and we are going to look into some examples of those very soon. Newton's second law, in some more complicated terms, but this is all we really need, is that force equals mass times acceleration. So the mass of the object times the value that it is accelerating by equals the amount of force. So that means as the mass increases, the force increases, and as the acceleration increases, the force also increases. So let's just look at a couple of problems right here to kind of illustrate that. So if we start with something that weighs 10 kilograms, has a mass of 10 kilograms, and is traveling or accelerating at 10 meters per second, multiply those two together, we're going to get 100 newtons. Now, we could double the mass of the object to 20 kilograms, but we're going to keep the same acceleration. It'll still increase the force. It actually doubles it because the mass has doubled. If we swap back around to the original object, but we're going to accelerate it twice as much, again, we're going to get 200 newtons, so it's still twice the original problem. And if we take both of those things, we increase both of them to 20 kilograms and 20 meters per second, we're going to have 400 newtons of force. So it's not anything crazy like the acceleration makes the force less. No, the mass increases, so does the acceleration. All of that stuff increases the force, and the opposite. If we took our 10 kilogram thing, we chopped it in half, same acceleration, then the force would be less. So it's all proportional, if you guys have used that word yet in math. Now, Newton's final law that we are going to talk about today, actually his final law in general, is for every action, there is an equal and opposite reaction. Now, I think this is definitely the most misunderstood of the laws. I think the first two make sense, if you just kind of absorb what they're talking about. This one is not immediately obvious and is very commonly misunderstood. So what is Newton's third law referring to? It is referring to force pairs, which we have done a little bit of work on. If a force is being exerted on an object and it is not moving, remember it is a balanced force, so there's no movement happening, the object is exerting the same force back. So if we're looking at our scenario here, we're having a person who is exerting 100 newtons of force down on the table. Because the table is not breaking, it is exerting the same amount of force upward at the person. Now remember back to our balanced and unbalanced forces. If we have a balanced force, there is no acceleration happening. If we have an unbalanced force, then there is. So that means if the person was exerting more force on the table than the table was exerting back, they would be falling straight through the table. Or if the table somehow was exerting more force on the person, then they would be flying up to space. Now, this also can be expressed in some ways that are in motion. So have you ever taken a bouncy ball, dropped it, and it goes straight back up at you? That is actually another instance of Newton's third law. It is basically redirecting the force. The equal reaction is the force hitting, or the ball hitting the ground is the action. Then the opposite reaction is that energy reversing direction and flying up into the air. Hopefully this helped you understand Newton's laws a little bit better. And I hope you all have a great day.